Hey everybody, this is Larry. This is day 15 of the Leetcode Daily Challenge. Yeah, okay. I was like, if I was wrong, then I suck at math, I guess. Hit the like button, hit the subscribe button, join me on this one, join me. So actually, I set this in my other video, in my extra bonus question video, but I forgot to say for today's video, or the daily problem video, and I think more people watch this. Community post on YouTube about it. So if you're watching it, maybe you have seen it. But basically, there are people impersonating me on Discord and apparently Leetcode, and no one has done anything about it. Short story short, or long story short, either way, a story short is that never gonna ask you. They're not ask you to invest in crypto or anything really, at least not for me. So don't give up any information or invest on anything. All right. The only thing I would say is, for example, is invest in SPY or VTI or something, like a big index, diversified whole sector index fund. If that's your thing, we could talk about that later. Not financial advice, but don't invest in any crazy coins that someone impersonating me will do. And then the third thing is, I don't want to know about that much about your life. All right, I say this in a gentle way, but that means that if someone trying to get your information, like your mother's maiden name, or I don't know what else, like your birthday, I don't know, whatever. For the most part, I will probably not be that interested. So don't tell them this information. In fact, even if I don't ask you, don't tell me about it. It's fine. I don't need to know. It's okay, right? So yeah. So please be careful out there. Stay safe. Keep your money to yourself. I will never ask you for money. With the one exception that I always say is that once in a while I would do a charity drive. I'll be like, hey, here, I would appreciate it if y'all donate to a certain charity, and it'll be a very famous charity, at least in the US. It'll be something that you can Google, and if you really feel like that's, I'd rather you do that. Donate money to a charity. So other than that, and none of that will go to me clearly, obviously, and go through me. And and it's a link that you could Google for yourself probably, and not like click on anything that a fake Larry would show you. Or even like from a real Larry account. Like, who knows? Maybe I would get hacked in the future on either this YouTube or Discord or whatever. I will never ask you for money, all right? I just want to make it clear. Just want to say it again. It's a long PSA, but there's nothing else I can do about it, really. They're not on my servers. I can't ban them. Apparently, Leetcode doesn't have things in place for impersonation, which I guess kind of, I don't know. I mean, how often does that happen? I don't know, right? So maybe that's a fair thing. I don't necessarily require, or would need them to. But my point is, be careful out there. I'm not gonna ask you for money. Maybe in person, I would look like this. Yeah. Don't really have much to say, I think. All right. I just want to get it out there. Thanks for watching the intro. I mean, for obvious reasons, right? Because yeah, I don't want anyone to get scammed. I want, and on my behalf too, because I don't even make money for this. So if someone got scammed, they make more money than I did from people. So I don't know. That just feels weird. In any case, I am in a good mood today. Next one, hopefully they win another in 2 days or 3 days. Yeah, Friday. So I don't know. Yeah, let's take a look at today's problem. Let's actually get started. Let's go. All right, today we have 2812. Find the safest path in a grid. Okay. You're given a zero index to the matrix grid. Oh yeah, one more thing. Sorry, I forgot. I just hit 30,000 subscribers. Just want to say, it's a weird thing to say after the PSA, but maybe that's why I needed this PSA, is because of all these scams. But my point is still, thank you for watching. Thank you for subscribing. If you haven't already, you could do it now. You could be one of those 30,000 people, and maybe 40,000 in, I don't know how long it takes. It takes forever. But anyway, all right, let's get started. Okay, so we have n by n grid. RNC represents a cell containing a div is 1, an empty cell is 0. Okay, so we have a grid like this. You start at 0, 0. In one move, you can move to any adjacent cell in the grid, including cell with divs. The safetiness factor of a path is on the grid. Factor, safeness factor, safety factor. Okay, fine. Anyway, of all path from to n1. Okay. What is the grade for? Wait, what am I? Maybe I misread this. Oh, all paths leading from cell and leading all. The maximum safeness of factors of all paths leading to cell n minus 1 to the corner. Okay, corner. Okay. I mean, this is a very weird way of saying it. One path. Wait, what? Maximum safeness. Okay. Oh. The safeness is such a silly word. Minimum Manhattan distance. Okay. So a path. So. Yeah. I mean, I don't quite have an immediate idea, but I think the idea that I would have is first is create the inverse of the graph, right, which is the safetiness of it, and then just do a depth, not a breadth first search, but I guess, or like a FUD fill thing, right? Yeah, which can be done in connected components of every cell. So let's do that first, right? So yeah, is that a real word? Safeness sounds so weird. Yeah, it's just safety. People don't say safeness, do they? I don't know. Anyway, okay, I'm just gonna. It's just such an awkward phrase or word. Okay, so yeah, so now we first start by get the safety numbers, right? Yeah, so then maybe safety as you go to, let's say, I get this weird thing where my keyboard sometimes gets, because it's Bluetooth connected or whatever, it gets disconnected. So that's why, like, I type and I have to wait for it to reconnect itself and then type. It's very awkward. I need to fix it, but bear with me. Okay, so yeah, and actually I want this to be infinity, right? And then now the idea here is that you could build the Manhattan distance one. So here we have, yeah, for, oops. So if this is equal to 1, then, oh, not safety, the other thing. So if grid is equal to 1, safety of ij is equal to 0. And then we want to do, yeah, just ij. I guess it doesn't matter, but all right, let's just do it this way. Nope. It should be a deck, right? What am I doing? All right. And then now this is just a regular breadth first search, which is, yeah. So then distance, xy, q top left, and then, yeah. And then we want the directions. Again, this is going to be a directions that is up, down, left, right. So we do up, down, left, right. And of course, oh, this is actually very wrong. Whoops. But yeah, the first part is the x, and the second part is the y, which is left and right, and the first part is up and down. So yeah, and then now we have for dx, dy in directions, right? And x and y is equal to x plus dx, y plus dy. Make sure that this is inside a grid. I guess we're doing grid problems. That's all we're doing, right? And safety sub nx and y is equal to infinity. Then plus 1 q dot append d plus 1 nx and y. And that should be good enough to give us the safety factor. I like to print it out just so that we can make sure that this works roughly. Yeah, and yeah, so you have 0, 1, 2, 1, 2, 1, 2, 1, 0, right? And now, basically, there are a couple of ways you can think about doing this. Right, now that we have the safety map, I think one thing that you can note, and you can exploit this, but you have to be very careful, is that the distances never drop off, right? And what I mean by that is that the safety factor, the safety numbers, the adjacent numbers are always only going to change by 1, right? And from that, because of that property, you can actually do something called a 0-1 BFS, which is a special BFS. But I don't think you even need it. I mean, I think that's a very cool way of doing it, but you do not need to do it. But that is based off the observation that safety, because it's based on Manhattan distance, it is just off by, it is only, it's only 1 off by to adjacent numbers. So I think that's a key, that's one thing that you want to think about as well. But we can, so another way that you can do it is binary search, and try to find connected components from the top left to bottom right. And you could do that with, well, I mean, connected components, which is BFS, depth of search, or union find, or disjoint set union. Let's take a look. 400 squares, a little bit big, but I mean, but I think that's mostly going to be the idea. Right? How is this 2? Isn't this cell 3? Because it's 1, 2, 3 away. Do we not count the 0, 0? Minimum Manhattan. I don't get it. Isn't this upper left corner 3 cells away? Oh, because it's okay. So the safety, maybe I misunderstood this. The safety is 3, but the path is 2 because you want to. Okay, the path. Okay, I think I swapped it in my head the other way around. Okay. Yeah, I mean, all the binary search, all the buffer search stuff will work, but yeah, do I just want to do it the other way? And you could, of course, also do it with Dijkstra or Dijkstra's algorithm as well, where the rate is going to be, the minimum path so far, which you could do that as well. I think that's an easier abstraction to think about. I think the 0-1 BFS is kind of tricky, to be honest, but let's just do it with Dijkstra. I think. Yeah, I mean, I think that's easier to understand. Okay. It is a very awkward problem, I think. But Yeah, I mean, I don't know. I think you can do the 0, 1 BFS, but you know what? YOLO. I'm gonna try the 0, 1 BFS. I might not get it right. I think if I have to guess, I've done it before because I saw that we had code. If I guess, this is probably done it that way with the dice drill. Let me double. Oh, it's only 9 months ago. Wasn't that long ago? Guess this was during a contest. Oh no, I did it with binary search that time, huh? Okay, that's actually surprising, maybe. Hmm. And I messed up the 0 case. Okay, fine. Yeah. But hmm. How did I mess up the 0? Oh, hmm. Isn't this 0? How did I mess that up? Yeah, okay. In any case, should I do it dice drill? Let me try to do it with the 0, 1 BFS, and if it works, it works. If it doesn't, then I learned something, and we'll do it the other way. The binary search is pretty straightforward. I mean, we did it, and I have a video on it, so I'm not gonna I'm okay with not doing it. But yeah, okay. So then now we have another queue, and then now we want to set queue.append. What do I want to append? So the save t of 0, 0, and then we're at 0, 0. And then what am I doing? Oh yeah, I want to make sure that we know that we visit this. Yeah, because we only visit each cell once, which is how we get a better complexity. Oops. I'm so used to writing R and C. That's why I'm like keep on slipping R's and C's in here. But yeah. Okay. I think there's also a case where if so D is the distance, kind of. XY is equal to q.pop left. And then now if x is equal to n-1 and y is equal to n-1, we can return D, right? And then now we do, up, down, left, right, again. Cannot type today, right? Same thing as before. If I can type and not visited nx and y, then we want to set it to true because we want to visit now. Right? Oh, I have to set 0, 0 to true, actually. I think we're okay either way, but well, it shouldn't change the answer. But then now, okay. So then if D is less than or equal to safety of nx and y, then it doesn't change. So then that means that we can keep the D and we could push it to the front, right? Append left. We want to do D, nx and y. Else D is bigger, so then now we have to keep track of the smaller number. So which is going to be safety of nx and y, which is the small number, but we do it at the end. I'm trying to think whether this may give us like a weird case. I don't think so, because this implies that this is the limiting factor. So if we go through another path and it gets there, I think it should work, but I'm not 100% confident. Maybe there's some edge case I missed, honestly. Okay. And then now this should never be true. So here maybe I just return -1 because it should return here. All right, let's give it a spin. Did I have some typo? What am I looking at? 48? Oh, whoops. Oh. All right, looks good here. Let's give it submit. I mean, we're trying something new, so I'm, happy to try something new. But wow, maybe it times out. Oh no, I mean, actually went way faster, right? But don't know why it took so long. Maybe I'm just having some internet issues. But in any case, yeah, that's all I have for this one. Yeah, I mean, in terms of code, let's go over the complexity. So this is the binary search one. I did it during the contest, I think. And yeah, and the binary search, you have, this is going. I did this part to connect the components with breadth first search, which is linear, which is n times n, right? And then here, this is going to be O of n, because that's the or O of log n. So this is n squared log n, right? This one, which is much faster, as you see, and 92% apparently even. What is the complexity here, right? I mean, this is just 2 breadth first search. So this is just n squared, which is linear, right? It's linear because the size of the input is n squared. So this is linear in the size of the input, which is n squared time, n squared space, and I am happy. That's all I have for this one. Let me know what you think. Let me show you the code real quick. I mean, they just do breadth first search. This is a breadth first search, and this is a breadth first search. The key thing to note is that they are different, though, right? This is regular BFS, multi-source regular BFS, multi-source shortest path from the div. Before you, shortest Manhattan distant path, right? Something like this. Okay. And here, this is a little bit different. And maybe I should write it out, but this is actually 0, 1 BFS, right? So it's a little bit different. Keep that in mind. And the difference is that for some cases, you append to the front because they don't change the answer. And that allows you to kind of converge earlier, but also it inserts it in the right place, kind of, if you want to think about it that way. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health, and stay safe. Don't get scammed. I'll see y'all later and take care. Bye bye.